Hey everybody, in today's episode we're going to do a quadratic word problem.
This problem is a bit involved and it's just a little bit dense.
It's dense, like bread.
Alright, so we're going to start with this statement here. Use the position equation given below, where S represents the height of the object, V0 is the initial velocity, and S0 is the initial height, and time is t. Alright, so they've given this equation, negative 16t squared plus V0t plus S0. An aircraft flying 650 feet over level terrain drops a supply package. How long will it take until the supply package strikes the ground? Okay, so the first thing is they drop the package. Right? They don't throw the package down, they don't throw the package up in the air, they just release the package. That's telling us here that the initial velocity of this object is 0. Alright, so this term right here is actually going to become 0. There is no initial velocity. The plane is just going to drop the package. Now, the initial height of the object is pretty clearly shown there. Hopefully you see that is 650. That's how high in the air the plane is. So for part A, our equation becomes S is negative 16t squared plus 650. Okay. Now, they say, how long will it take until the supply package strikes the ground? Okay, so they're asking how long. How long says, I don't know what t is, right? We've got to find out t. But that also means if they don't know what t is, we must know what s is. S, again, is the height of the object. S represents the height of the object. And so how long will it take until the supply package strikes the ground? What is the height of an object on the ground? That's 0, right? So 0 is negative 16t squared plus 650. And from here we can subtract 650 on both sides and turn this into a square root problem. So solving this quadratic is quite simple. And we divide both sides by negative 16. Alright, so we have over here two negatives, so I'm going to take 650 divided by 16, and it's 40.625. Now that is t squared, so we need to take the square root of both sides. And so on this calculator, hit the square root, and so they want 3 decimal places. So 6.374. Okay, so 6.374 is our answer here. Now part B is where this gets a bit dense. Alright, part B, the aircraft is flying at 134 miles per hour. So just a little physics discussion here. If this aircraft is going 134 miles an hour in the horizontal direction, that's what they're saying here. How far will this package travel horizontally? If the plane is going 134 miles per hour, the box or the package or whatever is also traveling 134 miles per hour. So when they let the package go, it's not going to go straight down the ground from here. It's actually going to go down and forward some. So we know distance is rate times time. Alright, so we know the rate, it's 134 miles per hour, and now we know the amount of time that it's going to fall. It's going to travel forward 134 miles per hour for a time of 6.374 seconds. That was what we got in part A. Alright, so we're going to take 134 miles per hour times 6.374 seconds. Now they're asking for the answer in feet, so we're going to have to do some pretty serious unit conversion here. Alright, so let me show you how to do that. 134 miles per 1 hour. Right, so in science class, perhaps maybe you learned this method where you focus on the units. I have miles and I want to get to feet. So I put the miles on the bottom and I put feet on the top. So my miles units will cancel. And now I go fill in that I know 1 mile is 5,280 feet. Alright, so now I have feet per hour, but I want feet. I need to get seconds because my time is in seconds, not in hours. So I do the same thing and I put hours And I can convert hours to minutes pretty easily. Right? 1 hour is 60 minutes. So you see we're essentially multiplying by 1 every time we do this. Now that's feet per minute, and I want feet per second. So 1 minute is 60 seconds. So if we take 134 times 5,280 divided by 60, we'll get, this is all just to convert miles per hour to feet per second. So 134 times 5,280 divided by 60 divided by 60. So this plane is traveling 196.53 feet per second. All right, that's my rate. So I have, move up here, distance is rate times time. So I have 196.53 feet per second times my time, which is 6.374 seconds. And that's going to cancel those units and tell me the feet. So I'm going to take that answer times 6.374. And so the distance this thing travels horizontally is 1,252.7. They want 1 decimal place. So rewind this, watch this part again as I do this description, but essentially I first convert miles per hour to feet per second, so that when I do this step up here, rate times time, I have feet and seconds, so that my final answer is in feet.